finding, let's start with the surface area because the surface area is the toughest. It is the toughest. It's always tougher. You don't want to have your formula sheet out. And you want to break it down into the different shapes you have. So if we want the surface area of this shape, how could we break this down? Yeah? Three separate cylinders, okay? So these two, will they have the same surface area? Yeah, so if I find the surface area of one of the weights, so this is a barbell. So I'm going to draw this a little, I'm going to try to draw this. Okay, now when we're finding the surface area of this cylinder, which is our barbell, I'm going to color it because coloring is so much fun. Okay, so here's my barbell. Thank you. Okay, is there something we need to remember about this barbell when we're finding the surface area? Yes, Taylor. Yeah. So we have this little circle here we're going to have to subtract off. Right. So now I'm going to, except for it's just on this side, right? It's not on the other side. The other side's going to be flat. It's just on this side. So if we want, it's always easier when you break these things down. Oops, that's not what I wanted. I want to finish my shading. There's my barbell. We're going to find first. Okay, so we're going to find the large surface area of our cylinder, and then we're going to subtract. So surface area of the cylinder, subtract what? Is that how I spell cylinder? I feel like it's wrong. It's an A, right? I don't know why I am having a brain fart. It's an I? Oh man, I can't spell today. You ever have days like that? It's an O? Oh yeah. Thank you. Please don't judge me. Okay. Don't ask. I normally can spell just fine. Today I'm really tired. Okay, minus the one circle, the small circle. Okay? Minus that small circle. So this is the surface area of the weights we're dealing with, and we have two of them. The two weights we're going to do first. Okay, so what's our formula for surface area of a cylinder, the big cylinder? Okay, so let's start with the surface area of the cylinder. I'll call it SCY, so I don't have to spell it. So we said there's two circles on the outside, 2 pi r squared plus the rectangle in the middle, 2 pi r h. So of this big cylinder, we're going to have to figure out its what? Well, in order to find the area, what do we need to know? Radius and the height. So the cylinder, what would actually be the height of this cylinder?
6.4 centimeters.
Right. So height, do not be confused with it, right? Because cylinder, we always put the circle on the bottom. So this here is really the height of our cylinder, right? Because we actually turn it. And then what would be the radius of this guy?
6.
Would be 6. If the diameter is 12, the radius is 6. Okay, so let's go ahead. We can find the surface area of this cylinder. So 2 pi times 6 squared plus 2 pi times 6 times 6.4 for the height. Once you finish writing that down, why don't you calculate that? That's the formula, right? Because when you open up that cylinder, it's a rectangle. Circumference is 2 pi r times h for the area of the rectangle. 467. Now let's go to 3 decimal places because we don't want to mess up rounding at the end.
Yeah, I got 467.468.
Let's over 4. 467.469. I'll try and work with my exact values. And what's our units here? Centimeters squared. Okay. Wonderful. So now what do we have to do with this? We need this small circle. We have to figure out the small circle. So small circle area, what's the formula going to be for a small circle? Yeah, it doesn't matter if it's small or big. Still pi r squared. So we need to know the radius of our small circle. What is it?
7.4.
The small circle here? 1.25, right? So if this is 2.5, half of that is 1.25. So the radius is 1.25. Okay. Pi times 1.25 squared. Now, if you want, could we just subtract it off right here? Or do you want to calculate it then subtract? Let's calculate then subtract, sure. Pi times 1.25 squared gives me 4.909. Centimeters squared. Okay, so our weight. So one weight, we're going to subtract the two. Am I going too fast? Okay, I'll slow down. Sorry. Yep. And then I'm going to times it by 2 because there's two of them, right? So let's find the surface area of 1. And then, yep. I don't know yet. I don't have it in front of me. Is that what you got? Is that what you guys, you're all done? You can go on to the volume then if you're done. Okay, so when you're actually subtracting, it's good to use the exact values. So I'm actually going to type this whole thing in, because then I know my answer will always be exact, minus my answer. Okay, so you should have had, did you guys get 462.560? No, just for the weights, for each weight. 560 centimeters squared. And so because there's two of them, what are we going to do? So the two weights, so we're going to multiply that answer by 2, times this by 2. $925.120. Okay, so we're almost there. So we're taking care of the two weights. Now we have, what's that in the middle? Anyone know what that's called? Is that the barbell? Which is a bar? The bar. Okay, so we want the bar. Now, the bar, what do we know about the bar? Okay, the circles are 4.909, but do we need the circles? Is that part of the surface area of our shape? Is that exposed to the air? So we're always thinking about what's exposed to the air. So again, I like the crayons. I'll do it in green. So we just want, right, the bar. So the bar is a cylinder too. And the formula for a cylinder is usually 2 pi r squared plus 2 pi r h. Which part of this formula do we not need? Yeah, Zach? Drop 2 pi r squared, because what does this stand for? The two circles on the front and back. And we don't want those because they're not exposed to the surface. We just want 2 pi r h. That's this part of the cylinder. Okay, so which part would be the height of our cylinder? Really the length, yeah. Remember, circles are actually the base. Turn it upright. So the height would be how much? 14.8. And what would be, we already know the radius, right? Yeah, Maddie? Times height, yeah. Yeah. And the radius we already figured out was be 1.25 because it's 2.5 diameter. Cut that in half. Okay, are we good to go on? You okay, Chris?
Yeah.
You done?
Wait,
Not yet.
find the volume.
We still have to find the volume, yeah. Times the height of 14.8. No, volume's easy though. Much, much easier. You don't have to worry about subtracting shapes off unless it's like hollow on the inside or something. No, it's still, there's only 2 questions for this lesson. I don't know if you noticed that. No, for the lesson. So it's going to go quick. 116.239. Did you guys get that? Yeah? Okay, so total surface area, what are we adding together? The 2 weights and the barbell, we want to add together. And what did they say to round to? Nearest cubic centimeter? Yeah, Quinn? This small circle here, because we're just dealing with this shape right here. Yeah? Because it's not exposed, right? We're talking about if we had to paint this surface, what would be exposed to the air? So when we did the cylinders, we had to take away this one little circle here. And then it's not volume of the surface area of this of the surface area of the weight. We take away this little circle here. It doesn't matter. We're talking about exposed surface. Exposed surface. Okay. All right. So adding these together, guys, if you can just stay with me even if you're done. So plus, I'm going to keep it exact. Okay. So what is it to the nearest? What does it become? Is that what you got? 1,041? So 1,041 centimeters squared. It's our final answer. Okay, it really helps if you label your work nicely. So you know what you can follow your own work. Okay? And ultimately what we're doing is we're taking our formulas and we're changing them. So if my formula is for a cylinder, why is it not showing? Oh, there it is. If I don't want, say, the 2 circles, then I just need the 2 pi r h. Or if I only want 1 circle, I could change this to a 1. Right? If I didn't want the circle on a cone, what would I take off? If I just wanted the side of the cone. We take away the pi r squared, it would just be pi rs. So we have to understand our formulas in order to make it easier on us. Okay, volume. Let's do volume quickly. So that's why I kind of had a vertical line here. Did everyone get that down? The bottom here, everyone has that down? Okay. It's like there's a yes. So volume, same idea here. Where do you want to start? Yeah, 2 weights. Okay, the weights again. Now, do we have to worry about subtracting things off when we're dealing with volume? No, we're just adding the 3 cylinders together. So the weights, start with that. What's the formula for the volume of a cylinder? Pi r squared h. Sub that in, pi. The radius of the cylinder again was what? Of the weight? Of the, yeah, it's 6. So 6 squared. Don't forget to square. A common mistake is forgetting to square. And then the height of the cylinder, what would actually be the height? 6.4. pi 6 squared times 6.4. If you have a calculator that when you square it actually puts it up, like actually it shows it as the power, you have to push the right arrow to get off of it. I don't know if you've learned that yet. If you have a fancy calculator. Okay, so what are we going to do with this number? Times it by 2. So the volume of the weights is actually, let's go to 3 decimal place, 1,447.646. What's the units? Centimeters cubed. Okay, now again, the cylinder part, the bar. Do we have to worry about subtracting anything off when we're dealing with volume? No, volume's so much easier. Pi, what's the formula again? Pi r squared h? Of course. So pi, the radius of our bar, we said was straight here, down here. Radius of our bar was 1.25, and the height of the bar was how much? 14.8. So pi times 1.25 squared times 14.8. And then what are we going to do with our numbers again? So here's my bar, here's my weights, and we're going to add them together. So the total volume, 1447.646 plus 72.649. Okay, was that easy? Ish? Nearest, did you get 1520? 1,520? Centimeters cubed. My final answer. Okay, so there's one more question we gotta do in our notes, guys. And it's a really good one. Very, very good question. It's like a test question, maybe. It is, but we should go through it really quickly. So when you finish copying this down, can you draw? So you turn the page and then draw the shape if you haven't already. Okay, so this is a unit test. This is the type of work I would expect out of all of you. Fair? For a test? I think so. Because really a test question, when it's like a proof. Every question you're showing on a test, it's like you're proving this is the answer. So you need to prove that this is how you got to it.
It's not really as much of a question and answer as much as a fill in the blank.
You're proving though that this is the volume and this is the surface area.
Yeah.
Right? Okay, does everyone have this down? Can I turn the page? How much do you have left to copy, Quinn? Did you just start? Okay. If you want to try it, the next one, you can. Just going to pause it. Okay, did you guys draw this? A ball fits tightly within a square box so that the side length equals the diameter of the ball. How much air surrounds the ball within the box if the box has a side length of 10 centimeters? There is oxygen in the box. It's not airtight. Thank you, Anthony. Okay, so it's a kind of difficult image to draw. We have our sphere inside. If you're as lucky as me, you have crayons to help. Or a pencil for the shading. In math class. Okay, so we have a sphere inside of this box, and it's very tight. What do we know? Yeah? Carolina? Okay, so the length of the box is the same as the diameter of the ball. Good. So how can we find the volume of the air? Maddie, yeah? Yeah, okay. Let's do something different this time if you are not already done. Let's do it all in one step. Okay, so what's the formula for the volume of a box? Or, if it's a box, a cube, x to the power of 3 if they're all the same. Okay, formula for a sphere. It's on the sideboard if you forget. Radius cubed. Okay, so what's our x? 10 minus 4/3 pi. What's our radius? 5. Could we type this in all at once? Yes. Okay, so if you're done, you can start on your homework. 10 cubed minus 4/3 pi times 5 cubed. Okay, did you get 476.4? Yeah? Centimeters cubed. Okay, that's an easy question. I like that question. Might even be a test type question. Yep. Okay, I'll take a look. So let's give me a second and I'll take a look. Okay, Janae? Homework from here, we have till 11:20, so we still have 30 minutes in class. Lots of time. So that's our homework for today. Take some time, yep. Okay, yeah. You know where to find the homework. And Janae, I'll take a look. Let me see.
That's the volume of the box.
Yeah, 10 cubed.
But then what's going on?
You squared it instead of cubed it.
Oh, okay.
That's why.
Okay.
Okay? It's actually pretty. I like that. Okay, sorry. Stop the recording.